Do you see the small little letters in the screen? It's so small. It's because sometimes we architects and builders in general, we all look for new buildings because they're more exciting to do. They probably give us more income. But then there are really much more existing buildings, and sometimes we don't see it. This is actually a very big market, a much bigger market for us people in the building industry to actually go into buildings. If you look at this picture, all of them are existing. They're built. And yet, somehow, we architects, engineers, builders, we try to look for new buildings. And how many new buildings do you see in this little screen here? So the reality is that we actually have more existing buildings. And when we talk about sustainability, all of this data coming out about energy consumption, like buildings consume up to 3/4 or 75% of all the energy produced in the world. That data is from existing buildings. That data is not from new buildings. So therefore, if you really truly want to make a more sustainable world through the built environment, which is our task specifically, then we'll have to take a deep look, a second look at these existing buildings, which actually consume so much energy, and turn them into green buildings. And I guarantee you that renovation, that greenovation is actually a much bigger market, if you want to embrace it, than new buildings. What can be done with an existing building? You know, as designers, we have been able to use so many creative words to describe what we do with an existing building. So we can renovate, we use retrofit, conserve, restore, repair, adaptive reuse. There's even a nice word which is called repurposing. So I thought, you know, with all of those jargon terminology going around in the renovation market, so to speak, maybe we have to sort of address that and look into it as more from the point of view, what can be done? You have an existing building, what can be done? And I've listed 4 things which you can do with an existing building. One is that you extend the use of the building. It's either repair it, restore it, conserve it. So that's one way of looking at an existing building, extending its use. Then we can upgrade that building, renovate, retrofit, remodel, put in new things there, technology, upgrade. Third, we could change the use of the building. That's adaptive reuse, no, or renovate, no. So it could just, maybe it used to be a mall, and now we're going to convert it into residential use. Actually, I read that recently in one of the articles, saying that some of the malls, which are dying, so to speak, in some areas in the US, are now being converted into residential spaces. And then, of course, the last one, if really there is no way of extending the use of the building, upgrading or changing its use, then we can demolish that building, but we try to look for ways in order to reuse or recycle the materials. So today, just 3 broad strokes in this presentation to share with you. First, I'd like to talk about green design concepts, but more of green design concepts which actually specifically help us to renovate the building or greenovate the building later. Okay, so this, when you're doing new design, you might as well consider these concepts I'm going to share with you, because then they will help you or facilitate greenovation in the future. Second is assessment. This is the stage in which, after you check the building, you assess the building and you make the decision, along with the owner, to whether you're going to continue with the greenovation or the building has to go to demolish it. And finally, the last one is the greenovation. This is the steps I've created. There are 6 steps in order for you to make an existing building a green building. I'd like to start out with a quick history. I always like to include these in the beginning of my lectures, especially on sustainability, because I know most of you, if not all of you, are very young, and you probably don't know what went ahead. You probably guys have just grown up into a world which is talking about sustainability, and you don't know what happened before. So very quickly, I think most of the concepts which we talk about now started in the 1960s in which a author, Schumacher, wrote a book called Small is Beautiful, and he espoused the word appropriate technology. This was in the face of globalization. No? It was at the time when the US was starting to have multinational companies. They would set up a shop in different parts of the world, and they would try to institute the same corporate culture in different parts of the world. And Schumacher said, no, no, it can't be. You'll have to apply appropriate technology in that area. Example, McDonald's. McDonald's is famous the world over for hamburgers. And anywhere you go in the world, the McDonald's is going to give you hamburgers. But, for example, take the case in the Philippines. Yes, we have McDonald's. Yes, they serve hamburgers. But aside from hamburgers, they have something which is local. Longanisa rice, right? You cannot find longanisa rice in McDonald's in other countries, only in the Philippines. In the 1970s, the oil-producing countries decided to clamp down on the production of oil. And this caused what is known as the energy crisis. Lower production of oil meant increase of prices of oil, and therefore the US at that time, which is relying heavily on oil to power up industry, to power up electricity, to get electricity and transportation, they had an energy crisis. And it is in the 1970s that the American architects, AIA, the American Institute of Architects, started to push the concept of energy efficient buildings, just in order to save money for the buildings which were relying so much on electricity. In the 1980s, the United Nations realized that if a sector of the world, like the OPEC, could control a vital resource which the world needs, then what about the other resources like food, water, materials? That's when they created or coined the word sustainability, and they actually put it out in the Brundtland report, no? To define sustainability at the time, talking about resources. And in the 1990s, since more and more people were trying to enter the world of sustainability, there was an opportunity for business to come up with this, what is known as the rating system. This is the famous green building rating systems. You have LEED in the US. In the Philippines, we have Verde, we have Green, and we have even a simplified rating system called EDGE, which comes from the International Finance Corporation, IFC. And in the year 2000, the idea of climate change started coming up, promoted by Al Gore in his famous documentary, Inconvenient Truth. No? So this is how things have been evolving, and that's why now we're in the age of climate change, and people think say that also we're in a climate crisis. And the buzzwords have been plastered all over media. No? Global warming, carbon footprint, greenhouse gas, climate change, sustainability, green architecture, resiliency. This has been going on and on and on for many, many years already. However, quick reality check. In the Philippines, a study made in Harvard, this was released in the October 29, 2020 in the Philippine Star. It said that only 11% of the Filipinos actually understand that climate change is. And that goes to show you why in the Philippines, there is very little move to do something about sustainability because people don't realize what is going on. So we have to change these things. We have to make it, change all of these complex terms into simple terms. And that's why when I show you later how to greenovate, you'll see how actually it is very, very simple. It's not complicated. So I would define green architecture also in a very simple way. My definition of green architecture is simply designing with nature, because this is from nature where we draw our resources to create our built environment. It is from nature in which we have the climate or the environment in which we actually build our built environment. And of course, many times it's also from nature where we draw the inspirations which we have for our design. And of course, always with appropriate technology. We design and we use the technology which is fit for the place we are building in, the climate we are building in, for the people we are building for. So sustainability is like this. It's like that little yellow house there with the red roof, with the on-the-line red roof. It's done, it occupies a space. Every time we build, we have to be conscious about, first of all, the space we are occupying, Because space in itself is a resource rather. And we have to make sure that we are ecologically and aesthetically harmonious between our structure and the existing built environment around us, and also our structure and the natural environment which is beside us or which we even displaced. So we have to look into that. We have to consider that. And resources are there, no? Sun, wind, and light are free. We have to maximize it. Natural light is there, no? Up for grabs. And we have to make use of it. And of course, sometimes there's water as a resource, and sometimes there are fantastic views in the project site which we are looking into. In terms of design approach, there are two design approaches for going green. One is passive strategies, meaning working with nature. For example, hot air will rise. It's a natural thing. Therefore, we can use that to be able to expel hot air on the higher portion of our building, allowing cool air to come in. Active strategies mean you need a little bit of electricity or some mechanical way to move it, like fans, etc. Of course, in terms of green architecture, we should exhaust first all the passive strategies, and then only then do we move into the active strategies. And then our target should be to make humans comfortable at a temperature of about 25 degrees centigrade, maybe about up to maximum 26, 27 degrees centigrade. And ideally a humidity of about 50 to 60%. That should be the target of our design. So let's go into the green design strategies. I divide it into 4 parts. Things related to the site, then the buildings, then the utilities, and then the materials. So quickly, site. Make sure that we always know what is the orientation of our site. Solar orientation. Where is the north, south, east, west in our site? And therefore, because of that, that's how we actually form our building. If you can see, notice here, the good circle. North is up, south is down, west is on the left side, east is on the right side. This is good. This building shape is good. Why? Because only a small side of the building is facing east-west, and therefore, you have less part of the building which is hot. And most of your building is facing north-south. Square is okay. This other one is, well, it's bad because then the sun is hitting it on the east and west on both sides. And this is the worst. In other words, most of your building is actually being hit by the sun on the east and the west. Then we have the wind. Where does the wind come from in the Philippines? Habagat, which is southwest, and Amihan, which is northeast. Therefore, you should be able to shape your building so that you can actually capture that breeze, run it through your building, so that you actually maintain a cooler temperature inside your building. Then we go to the building. What is the function of the building? The building has what is known as fabric and form. Form is the shape of the building. If you go back to the site picture I showed you, that rectangular building with the smaller side facing east-west, that's the shape of the building. That's the building form. So we use that form to be able to make our building cooler. And we also have what is known as the fabric. Sometimes technical books will call that fabric the building envelope. Okay, and what is that building envelope, the building fabric? That it consists in walls, that consists in windows, that consists in doors. Windows to let light in, to let breeze in, walls to block the hot sun from coming in. So the building fabric is the moderator of climate, whereas the building form is the barrier between the inside and the outside. Now, where to put your windows? See the scene? The north is here. North is pointing up. So if you have a building, try to avoid windows on the west side. If you have no choice, make sure you have vertical fins or sun baffles on there. In the east side, it's not so hot in the morning, so at least you can just put minimal windows. On the south, in the Philippines, make sure you have what is known as overhangs or media agua. Why? Because in the Philippines, since we are above the equator, the sun moves from east to west on the southern side. So we need to shade those windows. Then in the north, we can have the biggest windows possible because in the Philippines, we have the sun rarely hitting the building on the northern side. Going to utilities, water is a free resource. Rain is a free resource. So we can use fresh water to shower, to wash up, to cook. We can actually use that recycled water to flush our toilets. We can send that water into the septic tank and treat it. If you're a big building, you can use a sewage treatment plant. If not, you can use what is known as a reed bed. Then you can use that recycled water to either directly take care of the plants or even use it to flush the toilets again. There's a very important aspect in utilities when you talk about existing buildings, which will give you, remove a lot of headaches when you have to try to renovate or renovate an existing building. And this is what is known as pipe chases. You know, in architecture, sometimes we look at pipe chases when we do high-rise buildings. The pipe chases where all the utilities pass through, no? Because you're going up several floors. But even in low-rise buildings, even in single-story buildings, make sure that there is a pipe chase so that you can actually access your pipes without have to make back the walls, no? You can actually replace it. This is a project which you did. And if you notice, this narrow little door, if you open it, you can see all the pipes here. No? So there, this goes up all the way up to the top of the building. This is only a 3-story residence, but in spite of that, I have that. And that's why one time when the owners came to me after so many several years, and they asked, we'd like to add fiber optics into our house. Where do you suggest we pass it through? Then I told them, these pipe chases, they completely forgot about it. It's very easy. You bore a hole from the outside, run it through one of the pipe chases, so you can go vertically to the whole building and then go horizontally in each floor. No? So they're very, very useful. And it takes an architect to be able to determine where those pipe chases can be. Another example, this is a cabinet. You see this line here? I can actually slide that panel to reveal the pipes. Again, if I have to remodel, renovate, to change, to repair, those are accessible. These are just creative ways of how to hide your utilities, but at the same time access them. Actually, this project is a building which I actually have recycled water to flush the toilets and fresh water. So the blue pipe here, you can see the blue pipe there. The bathroom is behind this wall. That blue pipe is the fresh water. It goes to the shower and the sink. And this green pipe is the recycled water, which goes to the water closet so that you can use that water to flush the toilet. So again, very important, the pipe chases. This is going to go a long way. If you can start doing all your projects, no matter how small it is, by ensuring that utilities are actually accessible, the owners are going to kiss you when they have to renovate or repair because everything is accessible. In terms of materials, just look at how materials are actually created. No? You extract materials, raw materials from the earth. It's processed, it's refined, it's put in the building, it's used. At the end of the life of the material, it becomes waste. But that waste can either be reused, that means it's a green material if it can be reused. It can be recycled, steps back a bit, more processed, or if you dump it to the earth, it should be able to biodegrade. So that's a mark of a green material. There are so many materials now. They're dark green, light green, they're various levels of green. But the bottom line, if you want to make a simple assessment of whether material is green or not, a green material should be able to be reused, should have the capacity to be recycled, and if dumped to the earth, it should biodegrade. No? So that was quick for the how to design, but that's what I just highlighted the points which are critical or important when you look into greenovating a building. So let's go to the second part, assessment. Okay, so you have a project, and now you're going to assess whether it is worthwhile greenovating that building or not. And there are 4 parts to this. First, the as-built plans, then the audit, assess the building, and then do a building survey, and then equipment survey. And this is going to determine whether it's going to be a go or no go for the project. So first, as-built plans. It's important to try to see if you can get the architectural, structural, electrical, plumbing, mechanical plans and specifications for that building. Why? Because Many of the utilities are actually embedded and you do not see it anymore, no? And it's no way to assess it. So find out if you can get the as-built plans. If you cannot do the as-built plans, then you'll have to do the tedious job of doing as-built plan by yourself, meaning measuring up the place, creating the architectural plans, floor plans, trying to guess the electrical plan, trying to guess the plumbing plans and mechanical plans. But important thing, get the plans as built, because then it makes it life easier, no? Be able to plan or replan based on the as-built plans. Sometimes if the owner doesn't have the as-built plans, you probably can go to the building official. At least you have a start. That is the building permit plans which were submitted to the building official. Something to start with, no? So get the as-built plans to start with. Second, do an energy and cost audit. Why is this important? Because if you're going to, especially this happens when you have more in the corporate world, if you're going to try to do something, repair, renovate, except the building, you have to prove to management that you're going to, it's actually worthwhile. No? It's going to make, you're actually going to be on the blue or the green, if you want to say it, not in the red in terms of financial consideration. So first of all, try to see if you can get the electrical consumption of the building and the cost. Better if you can get at least a year worth of data on the electrical consumption, the kilowatts per hour, and the cost of that kilowatt per hour. Then get the water consumption and the cost of that water consumption of the building, no? Because then you can assess whether really this building is consuming more water than normal or it is just right. Then the cost of maintenance of equipment over the lifetime of the building. How much is costing to keep and maintain the air conditioners, the pumps, the elevator, etc. No? Because maybe you might be spending so much money that the money you've spent probably in the maintenance of some equipment could have purchased new and even better equipment. And then this one is a survey, evaluation of the comfort levels. In other words, look at the building, ask the people in different, you can pass a survey on how they are actually feeling. If they're comfortable, is it hot? Is it cold? Is it glaring, etc.? So that you can assess that comfort level and maybe make a correction in the new building. No? Then, looking at data. So once you have that, you have all the data, then you go into the building data. So for example, get the site data, find out what is solar path. If you look at this is what is known as the solar path of a specific location. This is Manila. Get the average temperature every month, external temperature, so that this way you're able to calculate how much cooler you can actually bring the building to. Then get the rainfall data for that area. Because then this data is important whether you can collect sufficient rainwater and harvest it to be able to use it for the building. Then check the wind speed and direction of your building. This is what is known here on the left side, lower left side, as the windrows. This will tell you the direction of the wind and the strength of the wind, because this can help you actually channel the breeze into your building. And of course, topography, the slope, so that you know where the water is going to normally go to. Get the air quality, the particles per million, to figure out how polluted the air is outside the building. The noise level, decibels, noise outside the building and noise inside the building, and see whether there is little difference or big difference in the levels of noise. Check the existing vegetation around you. And then also check the wind affected by adjacent buildings, because even if you have the windrows diagram, it is possible that because of the positioning of the buildings around your building, either the wind is blocked or the wind is actually faster because it gets funneled between buildings. Then look at the form of the existing building. Many of the green building rating systems look at this, no? Surface to volume ratio, external surface of the walls and the volume of the building. Then the glazing ratio, the ratio of windows to wall, and then the building orientation. And then look at the physical condition of the building, the structure, whether the structure is good. Check for water leaks. You know, if you see brown stains coming out of columns and beams or slabs. That's a very dangerous sign. It just means that there's a crack, water has seeped in into the steel reinforcement bars, and they are corroding. And that's why it cracked the slab, and therefore you have brown water stains coming out. Check also for air infiltration and others, depending on what building type you are doing and what is more important in that building type. Then check the equipment, condition of the equipment and maintenance. So check the air conditioners, the pumps, the elevator, escalator if there is, the fans, blowers, electrical panels, wires, controls, and others. Having said all of this, you are not going to check the building by yourself. It is beyond the architect. Bring in your consultants, your structural engineer, your mechanical engineer, your electrical engineer, plumbing engineer, sanitary engineer, and go with them together to look at that building which you are about to greenovate. So, why would you greenovate a building? One, it's degrading, decaying. The building is outdated. The building is inefficient. The building is unreliable. It's unhealthy. It causes a lot of people to get sick in that building. Change of occupant and use. Excessive operating cost. Complying with legislation. For example, I know sometimes when there's road expansion, sometimes your buildings get cut in the front. So you have to it's an opportunity to might as well fix up the building while it's being cut. Expansion. And then, of course, architectural conservation. So these are the many reasons why you might as well look at an existing building and move it into the green world. There are many benchmarks, but this is one interesting benchmark to check whether your existing building is actually consuming more energy than necessary. This is known as the EIU, Energy Intensity Units. It's electrical benchmark. The unit is kilowatt hours per square meter per year. That is why I mentioned earlier, it's good for you to be able to get the consumption of electricity for that building. And what you do to be able to use this benchmark is to get the kilowatt hours per square meter per year from the Meralco bill, and then get the square meters of the building. And that figure, kilowatt hours per square meter per year, should approximate these figures which I'm showing here. So offices should do only 200 kilowatt hours per square meter per year. That's the energy efficient benchmark. A mall should consume 300 kilowatt hours per square meter per year. A supermarket, 250 kilowatt hours per square meter per year. A hotel, 250 kilowatt hours per square meter per year. And houses, 50 kilowatt hours per square meter per year. Now that you know houses, maybe your assignment for tonight or first thing tomorrow morning is go and check your bills for the last year of your house, get the air of your house, and calculate. Are you close to 50? Are you way above 50? If you're below 50, good. You have a fantastic energy efficient house. But if you're going way beyond this, then it's opportunity for you to look into that and start looking at the possibility of renovating your house. So what are the advantages of retrofitting or greenovation? First of all, it's lower capital cost than a new building because at the least, you already have a structure. Even if you replace all the plumbing, all the electrical, you have a structure. So it's already lower cost than coming out with a new building. Second, it's a short time for completion. Precisely, if you have the structure up, then it makes you, it speeds up the construction time. Retrofitting also gives you an opportunity for energy efficient strategies, which we'll mention later in our GREENovation roadmap. And finally, above all, if you don't demolish the building, it is an existing resource. And therefore, using an existing resource is the most sustainable strategy of all. Okay, of course, somebody always mentions, well, a building which is not built is still the greenest because you don't use any resource, you don't use any energy. But look, we are still creating the built environment to house people. And therefore, we have to make sure that we use the existing resources already available to us and make sure that it is sustainable. So to approach retrofitting, you can do it in different strategies. Okay, it's not like one go. You can have it. For example, one way is doing retrofitting based on building element life cycles. For example, an air conditioner has a life cycle. Therefore, instead of just changing the air conditioner in the middle of its life cycle, wait for that air conditioner to reach the end of its life cycle and then change it. Scale of intervention. If you can actually start out your GREENovation by simply replacing your lights from maybe halogen and incandescent lights, and maybe even CFLs into maybe LED lights, starting out with those lights which are on practically the whole day. You can also look at what is known as retrofitting packages. What do I call these retrofitting packages? For example, in the survey you did for the occupants of the building, there's one area of the building which people are complaining it's so hot. You go there, you look at that room, and first of all, you realize, well, no wonder that room is facing west. The sun in the afternoon comes in and heats it. So how do you retrofit, solve that problem? It's a package. It's not just one solution, but it's a package. For example, maybe you can put louvers or vertical fins or sun baffles outside that window. Then maybe you can actually sort of insulate the upper portion of that structure. And then maybe you can also look at an air conditioner and maybe combine it with fans so that it moves the air conditioner around. No? So these are what is known as retrofit packages. No? So there are many ways. No? It doesn't have to be one full go. You can actually intervene in small little increments of an existing building. So now we go to the path. There are 6 steps, and they are in order. Okay, first, look at the building envelope and the fenestration. Why? Because with the building envelope, you already start creating a pleasant interior environment. And then once you have that pleasant interior environment, you look at air conditioning, because air conditioning consumes the most electricity. Up to about 60% of the electricity in a typical office building goes to air conditioning. So look at that and the ventilation. Then third, lighting. Lighting consumes about 20% of the electricity of a standard office building. Then you look into the water. Then you look at the materials. Then you look at the possibility of introducing renewable energy. So before you do that, again, when you go to GREENovation, don't do it alone. Remember, this building is existing already, so try to pull in your consultants, even the owner, on board and meet on the project. Okay, so this is what is on integrated project delivery. Get your engineers, contractors, etc., all on board as you start. So first, the building envelope. No? So first, what is the object of the building envelope? Keep the heat out so that it's cooler, and therefore you need less air conditioning power. Bringing the light in, natural light, so that at least you don't have to rely on electrical light during the day. Where do you bring that light in? From the north and from the south. And then control the air. Control the air, meaning if you can bring in breeze to maybe flush out the air so that you have fresh air, or you can actually use it to filter the polluted air outside so that by the time the air goes inside the building, it's much cleaner. So look at this thing. For example, you have this existing building. Let's say this existing building. Ideally, try to solve the problem before it enters the building. So let's say this is the west. So outside the building, you can actually put a vertical sunshade. One strategy. If this wall is dark, make sure you have a lighter color so that it actually does not absorb so much heat. Then, if you have a roof, try to make sure you have to insulate the roof above. Onduline has actually a solution. Even if this is a GI roof, an old GI roof, you can actually put the Onduline roofing on top of that with an air gap, and that actually creates a very good insulation system. Air is a very good insulator for heat. Okay, so that's one solution. Sometimes you cannot touch the outside for regulations or whatever. Then your next approach would be work inside. Look at this same building. If this is west. In the inside, see if you can actually install internal vertical sunshades, and then create a double wall inside so that there's an air gap here, so that even if the sun hits it and the heat comes in, there's still an air gap, so there's way to dissipate the air. And of course, insulate the under the ceiling or under the roof if it's possible. No? On the north, you have the opportunity to actually create a full window. Let's say, for example, this in the original building, you have window here and then wall here, no? Typical 900 millimeters above the floor. You can actually open it up, break it open in the north, and even have a full window because there's no sun entering your building from the north. Therefore, you can bring in a lot of natural light inside. You can even use what is known as a light shelf. This is the light shelf. In other words, natural light comes in, it bounces off here, and brings it deeper into the building. This will work fantastically, especially even if you have a white colored ceiling. Sometimes there's no window on the west, but then, at night, that wall becomes very hot because, the heat actually radiates. There's a concept called a double wall. Example, you put an element here, there's an air gap, and should main wall. The function is that if this is the west, the sun bears on this wall here, the heat moves into this air gap, hot air will rise naturally, goes up, escapes on a hole from above, and actually comes in from below. This is even another use, although, of course, Onduline is a roofing material. You can actually put a light structure here and put the Onduline sheets here, and it actually works the same principle. Sun hits here, it heats up the air here, then your inner wall is much cooler. This was asked. Somebody asked me recently. I posted a post in my Instagram, my LinkedIn, about avoiding windows on the west. He said, "What if you have a nice view of the sunset?" So this is the solution. If you have a nice view of the sunset on the west, like for example, you're building in Boracay on the Long Beach, you have a nice view of the sunset. Then you can actually do what is on installing a trellis. This is the trellis, so that in the early afternoon when the sun is still hot, the sun bears here, it still gives shade to the window. And then as the sun goes sets, it actually will give you a view of the sunset. At the same time, it's not so hot anymore. So that's one solution. Sometimes you have systems in which you cannot have open a window on the west side, but then you need light. So this is one solution. This is like a bay window, push out the wall a bit. This can be actually slit windows, can even be as small as 30 centimeters wide, so that you can actually have light coming in from north and south, at the same time blocking the sun coming into the room. Sometimes the west comes at an angle. We can actually just push out a little bit, have a slit window there, and you're actually having natural light coming in from the north or south, and at the same time blocking the sun rays from the east and west. Now, with regard to air conditioning, preventive maintenance is still the most important. When you inspect the building, look at the filters, the ducts, the blowers, because look at this, no? In central air conditioning system, all of these blue little lines here, they're normally the areas where the air can leak out, no? And if you have air leaking out, cold air, you're wasting that cool air. So how do you do renovation or GREENovation in a building with regard to air conditioning? First, aside from preventive maintenance, look at zoned usage. What is zoned usage? Analyze the building use. Are there areas in the building which actually use aircon 24 hours? Are there areas in the building which uses only the air conditioner at night? Are there areas in the building which only uses the air conditioner, for example, during the day, and there's nobody there at night? Zone them, cluster them together so that you can actually put a smaller aircon to run for 24 hours for that zone, which is used 24 hours. Another aircon, which is used only during the day for that area where they only use during the day. And another one maybe for the area which they only use at night. Therefore, you don't have to run like a central air conditioner, so powerful, and just putting aircon in just certain areas which is needed. So zone the usage. This one you can talk about. The next one is converting your variable drive system to from continuous variable drive up to variable. Oh, I forgot already thing. But anyway, as your mechanical engineer, do you know about this? This is a more efficient way of moving your air around. Then look at temperature controls. No, ideally you should be able to only hit 25 degrees. Some people use 18 degrees and everybody's in a jacket. Sayang lang yung cooling energy for that. No? And then look at energy efficient aircon systems. This picture here is what is known as a solar assisted air conditioner. The refrigerant can be actually exposed to the sun, and then that refrigerant actually can cool the building. No? These ceiling fans have been popular lately. No? These are large fans moving very slow. They're high volume, low speed fans, and they can actually move volumes of air. And consequence of that is that even if you don't have a very strong air conditioner, you can actually cool sufficiently your space. No? So let's look into ceiling fans if we can do that. Then allow for fresh air entry. Now that COVID is sort of very upon us, all the more fresh air becomes very important. No? So be able to flush out the stale air every night, for example, in your building, so that when you come the next day for your office building, you're actually starting up with fresh air, no? Cooling fresh air. And lighting, no? See if you can prevent making sure that you have actually maintain your lighting. Preventive maintenance and lighting is actually there. You see this CFL, the CFL actually gives you a headache, especially the one with like a spiral, because sometimes this gathers a lot of dust, and therefore it reduces the efficiency of the light. So maintenance means you have to clean it and wipe the dust out there. No? So if you have the possibility, start changing the lights from CFL or halogen into LED. No? Because then it becomes more efficient. You can actually control your lights this way. No? If you have natural light coming in from here, this set of lights closer to the window should have a separate light switch from those farthest away from the window, because during the day, you don't need the lights beside the window. No? So it's an opportunity when you greenovate to change the switching systems of your lighting. Then label the switches in a logical arrangement. I'm sure you've experienced this when you go to a large open office. You start switching on the lights, and it's not, you turn on one, oh, it's not your space. You turn on the other, it's not your space. So sometimes in a hurry, you just turn on all the lights, even if you're the only person in that room. No? So label the switches. Then determine in the room general and task lighting. Task lighting, it's a very specific high illumination for task lighting. That can be just in the area where the persons are working. General lighting doesn't have to be that strong. It can be like in the passageways. Therefore, we can use a lower intensity of light there. Then look for a way to make sure your walls, floors, and ceiling are lighter colors, because they can bring in natural light from outside. And at the same time, even if you have artificial light, they actually make the artificial light a little stronger, no, and brighter. And then look at possibility of light shelves and reflectors. In terms of water, look at rainwater harvesting possibilities. If you have a house already built and it's complicated to actually repipe, the simplest way is actually just to put a drum at the bottom or the base of all the downspouts, and then use that to water the garden, clean your car, etc. You can actually recycle or treat gray water and black water. You can actually look at the possibility of installing STP if the building is so old, or if it's a house, you can actually treat the water from the septic tank into what is known as a reed bed system. You just Google that term, reed bed or engineered reed bed. And then you can look at the possibility, if you actually have harvested rainwater or recycled water, look at the possibility of having a dual pipe system in the house. No? In other words, look at this picture here. No? This is the same project which I have recycled water. The green pipe is for the recycled water, and the blue pipe is for fresh water. And then, of course, nowadays, it's so popular now, these dual flush systems, smaller button for the minor operation and the bigger button for the major operation. This makes you save water ultimately. No? And when you look at you're going to change the fixtures, look at the water efficient guidelines. For example, for urinal, make sure you get a urinal which has only 0.5 gallons per flush, a water closet which is only maximum of 1.6 gallons per flush. And then in terms of showers and lavatories, look at the lavatory which is going to give you 0.5 gallons per minute, and a shower which gives you 1.5 gallons per minute. One very simple, quick solution to a shower in your houses, for example, is to get a shower which has an aerator. You Google that. An aerator means that as the water goes through the shower head, it turns a small turbine, it brings in air, it gives you the same power, strength of water, but it actually delivers less water. Now you can actually test that by using a pail. Okay, so these are little quick fixes for your house. Many times we have these clean outs. Now this is a catch basins. In other words, A storm drain comes from here, goes to catch basin, turns, continues. And this is one of the consequences why we have floods, because we actually flush out our stormwater very efficiently into the lowest part of the city. So one greenovation strategy is to break the floor of all the existing catch basins, then fill it with sand and gravel, so that as the water moves through the system, a bit of water is always brought back to the water table, and then it continues. This way, you're actually, first of all, recharging the water table, and secondly, you're reducing the volume of water reaching the street from your building. Then we look at the materials. Look at this. This is yucky, no? Mild molds and mildew, no? So indoor air quality is actually affected by the materials we have, no? So for example, look at this, no? If you see this, that means there's a high level of moisture here. We have to take this out because this becomes a very unhealthy environment. Look at also the dust, no? How much dust is going through those gaps between the windows and the doors, no? Then check also for carbon chemical contaminants like carbon monoxide. Maybe from the parking area, carbon monoxide is actually seeping into the building, or we are beside a heavy street and all the jeepney and tricycle fumes are getting the building. And check for volatile organic compounds. No? So total environmental quality, indoor environmental quality involves all of this, and we should look into this. No, one is thermal comfort. We discussed it already. Make sure that they're comfortable with about 25 degrees centigrade. Acoustics, again, check the level of noise. It could be very annoying. We might even have to use maybe a double pane glass, insulated glass, so that we reduce the noise coming into the building. Lighting can be glaring, so make sure we have the right lighting. Ergonomics, the positioning, the heights of different things, the spaces we have. Occupant controls, people like to control their lighting, people like to control their temperature, give them the possibility to do that. And of course, the quality of air, make sure you actually have fresh air running through the building. And then looking at renewable energy, we can actually put solar panels. Check out the building. We don't have to power up the whole building with solar panels, but we can maybe introduce solar panels. Like for example, solar panels, maybe they can be used to light up the lights which are on the whole night, for example, or all the staircases, etc. No? So we can actually just do it little by little. No? So to recap, the green design, is actually designed with nature, appropriate technology, and one of the most important take-homes I'd like to share with you in terms of green design for greenovation is pipe chases. Please put pipe chases so that you can access all your utilities anywhere in the building, so that you can actually facilitate your greenovation in the future. No? Second step, the assessment. Before you start kicking off the project, make sure you have gathered all the as-built plans. If not, try to create them from scratch. Do an energy audit. Check the electricity bill for the year and water bill for the year. Do a building survey, the location, the solar path, the sun path, the temperature outside, the rainfall, the wind direction and strength, etc. Then do an equipment survey. The answer to all of this will make you decide whether it's a go or no go. Now, if it's a go, then go through this process. Look at the building envelope. The objective is to reduce the heat coming in, introduce a lot of natural light, and have fresh air running through the building. Second, air conditioning. Make sure it's energy efficient. Introduce the possibility of having fans to assist your air conditioner. Lighting. Make sure it's energy efficient, and look at the possibility of adjusting the switching system so that you don't waste light during the day. Water. Harvest rainwater and recycle water. Materials, look at the health and the indoor environmental quality. And then finally, look at renewable energy. I'd like to share with you one of our projects, which we did. So this on the left side is the building. This building was an abandoned building because the one who put up the building could not pay the loan. So the bank repossessed the building. And I had a client who was looking at that building and wanted to buy it. But then, of course, we had to check the building, whether it is worthwhile. So we actually did exactly what I said. First of all, we asked for the as-built plans. There was no as-built plans, no? Because, of course, the owner probably threw it away because he was going to be ejected from this building because he couldn't pay the loan. The City Hall was not very cooperative, no? This is a very old building already. So first thing I did was a structure. So I got a structural engineer to go through the building and give him his assessment. He recalculated it and he said, okay, it's okay. Since we did not know the electrical and sanitary, we actually replanned the whole electrical system. This is the proposed building design. We actually punctured even in the middle a shaft so that we could bring in natural light and ventilation to the internal bathrooms. And this is the building when it was almost finished, ready to, well, shortly before it was turned over. No? There, no? So you don't have to always look for new buildings. This is an existing building. The client got us to fix it up. And now you have a very useful building, which is energy efficient. It's not demolished. And therefore, it actually has contributed to society. So I'd like to end with this little statement here. It's in my Green Architect series, which many of you know that I actually post in social media. So this tip goes as follows. There are more buildings that are existing than those that are being designed. So therefore, retrofitting these existing buildings for GREENovation promises to be a big market for green architects. So gentlemen and ladies, let's see if we can embrace this thing. Let's not always look for new projects, new buildings, but look at that big bulk of existing buildings. And that promises to be a very big market. And not only that, if we're able to greenovate the existing buildings, then we're going to make a bigger impact on the sustainability of the world rather than looking at new buildings all the time. So with that, I'd like to invite you. You can check out my Facebook page. It's called The Green Architect. I post, it's a very active page. I post lots of tips there. And I'm sure that hopefully you can actually get a few tips there. So with that, maraming salamat po. I hope that I was able to convince you to look at existing buildings